This is the demo for the Music AI project for the Human AI Interaction course, and I'm going to be talking about three main things. That's a walkthrough of how the model works and how users interact with it, the system's architecture, and then the design decisions and how the concepts that we learn in class factor into these decisions. So first, to explain how this works, the model basically has two main controls. That's the left and the right hand. The left hand determines the level of creativity. So closed fist is less creative, closer to the training data set. The more fingers we have up, the higher the temperature, the more creative the output. And the right hand is the one that actually controls the note generation. This is slower notes and higher speed notes. That's for the x-axis. The y-axis controls the pitch, so this is higher pitch, this is lower pitch, and hand openness determines the harmonic layer. So this would be closed fist is just single notes, and the more we open up our hand, that would generate chords. Right now I've set it on pretty conservative ranges so that it generates a more musical output, but I mean we can just play around with the speeds, the pitches, how creative the output gets. I'm gonna show it work with actual music. Like I said, I'm going to go for a conservative creativity level. You can see slower notes, higher notes, lower notes. I'm going to ask it to be more creative, higher creativity, more chords. And then there's different ways for me to generate this output. For the architecture, I used OpenCV for the video capture, MediaPipe for the hand detection. I pre-processed a data set that was completely public domain, no copyright. That was music from Chopin from 3 different websites. Then I trained an LSTM, a neural network that had 2 hidden layers and then 10 epochs. And then we have the final model. As for the design decisions, the aim was to make the model highly interpretable. That was with a really simple modular design and controls. So as you can see, it's got only 3 main controls or 2 main controls, the hands, but then 3 parameters that you can control with your right and then 1 with your left hand. And all of the code is publicly available, so fully transparent, and again, to help with interpretability. And then we also looked at this to be highly explainable. That's why the output is both automatically generated in GarageBand. You can see the notes that are being generated, but also you can see here that we have the normalized hand detection in real time. So we have the number of fingers we have up, we have a normalized speed, normalized pitch, and then the hand openness, so that this model is highly explainable and that so the users can fully understand it. Also, fairness, we used public domain music with no copyright, completely open source as to avoid, again, any copyright. And this is also looking to respect privacy because we're not collecting any data from the users. The users tested this. 5 different people gave me feedback for this model. They thought it was very interesting, very easy to use, the controls were not complicated. The feedback that I got is to get more creative with the way the users can interact with it, maybe having emotional settings on the left hand, having more nuanced control with like maybe the level of the fingers, how much it is opened up, maybe different gestures as kind of like an orchestra director. But again, users tested it, thought it was interesting, and there is a roadmap to train it on a more robust data set that looks at more musical trackers to generate a more musical output in the future. Thank you.